I'm Kendall Giles, and this is the TechnoSlipstream podcast, where we try to better understand technologies and their impacts on society through analysis and critique. This is episode 35. For those of you who are new here, the topics we typically discuss fall under three main themes. One, understanding our socio-technical world. Two, mastering new and emerging technologies. And three, designing a future worth having. In today's episode, we're going to discuss a topic that covers the first two themes. And that topic is AI and consciousness. In particular, we're going to discuss three main questions. Is AI conscious? And the second question kind of actually gives away the answer to the first one. What would it take for AI to be conscious? And finally, what would it take for us to know whether or not an AI is conscious? So lots of juicy socio-technical goodness to unpack in today's episode. But before we get started, I do just want to mention that I'm trying something new today. Actually, two things. In addition to recording the audio of my voice as normal for the podcast, I'm also recording video. So, hey, so you have the option of listening to the episode on your favorite podcast player as normal, or in addition, watching the episode on YouTube. You can find links to both on technoslipstream.com. One reason I'm adding video in today's episode is that some people like watching their podcasts and listening to them as well. So video is a good option for that. But also, because of today's socio-technical goodness, I'm adding slides. So professors love to talk with slides. So in particular, I think the slides will benefit just because this is kind of a nuanced topic. So I will have some slides to help illustrate certain points. I'll also describe everything as best I can for those of you who are just listening on the podcast. But again, you have the option of checking out the video as well. And it's just me being producer and content creator. So I'm here in my studio trying to manage all of the cameras and microphones and recording workflows. So your patience is appreciated as I try to push the right buttons at the right time. Okay, with each new version of some artificial intelligence models that keep coming out, some people are thinking that AI will soon cross the line into being conscious, if not super intelligent, what some call AGI, or artificial general intelligence, and others call ASI, or artificial superintelligence. Either way, as their thinking goes, once we create an artificial superintelligence, this would lead to technological singularities, or a singularity, or it's at the point at which technological growth would happen so quickly, uncontrollably, and irreversibly that humans would face an existential threat. And some people even think that that line has already been crossed. For example, as we discussed in a previous podcast episode, in 2022, Google engineer Blake Lemoine was fired, in part because he went public claiming that Google's large language model chatbot, at the time GPT-3, was showing human-like consciousness. And now we're way beyond GPT-3. That's an old version by today's standards. So the question is AI conscious, or is it soon to be conscious? So that question is a growing concern among more and more people. So when Andrew Maynard mentioned a few weeks ago that a new paper from neuroscientist Anil Seth came out, I thought that would be a great deep dive topic to take a deep dive into Seth's paper, and would be a great opportunity to share that with everybody here on the podcast and video. So let's dive in. I wanted to get one question out of the way before we get too far into our discussion, and that's the first one. Are large language models that power various chat bots that we have today, are they conscious? as ex-Google engineer Blake Lemoine believes? In short, you probably guessed it already by the questions that I wanted to discuss, questions 2 and 3, but the answer is no. They are not conscious. The reason can be seen by opening the black box of how these types of algorithms work and looking at the mechanisms that are going on. Large language models, which are trained on immense amounts of text, for example, blogs, articles, books, movie transcripts, social media posts, and most anything that these companies can scrape off the internet, in addition to other texts that are supplemented, they essentially, with all of these texts that you use to train these models, they end up operating like what AI researcher Emily Bender and others describe as a stochastic parrot. So based on a given prompt, such as, may the force be with, that you give to the large language model, the algorithm picks the next most probable word that would most likely follow the prompt based on the corpus of training documents that it looked at before, during the training phase. So there are a few more code sprinkles and options going on than that simple explanation, but that's basically what's going on behind the scenes. But I've not yet seen a definition of consciousness that would fit this most probable next word algorithm that is the basis for these large language models. And so obviously, the large language model would most likely pick, may the force be with you as the next word, rather than computers or something, some nonsense word. So no, large language models are not conscious, despite the claims of ex-Google engineers like Blake Lemoine. So this is a good time for me to introduce the slides here. And so as you can see, I've got where's the little pointer? Okay, right there. Okay. It's interesting because this is actually not the first time people have thought that chatbots were conscious. In the 1960s, for example, there was a chatbot named Eliza. Operated extremely primitively compared to today's ChatGPT, but even Eliza was able to fool people into thinking it was human. So one characteristic or complication humans have in thinking about consciousness is that humans, by their very nature, can easily be fooled into seeing intelligence in other things like chatbots, especially when human language is now the interface to these AI models. And you can see on the slide a quote from AI researcher Margaret Mitchell, who said, "Our minds are very good at constructing realities that are not necessarily true to a larger set of facts that are being presented to us." And speaking about increasingly capable AI models like ChatGPT, she said, "I'm really concerned about what it means for people to increasingly be affected by the illusion." And I'll just add that with each new version of these types of models, the sophistication increases. The illusion that we are chatting with a conscious intelligence chatbot is getting better and better. So this is increasingly causing problems when people make unhealthy attachments, emotional attachments to their chatbots. So now this brings us to Anil Seth's paper. Seth is a professor of cognitive and computational neuroscience at the University of Sussex, and also a director of the Sussex Center for Consciousness Science. He's also the author of, as you can see on the slide, the best-selling book, Being You, A New Science of Consciousness. Now, a preprint of his new paper, Conscious Artificial Intelligence and Biological Naturalism, that's what we're going to be doing a deep dive into today. This paper will help us think about the question of, okay, if chatbots today are not conscious, what would it take for AI to be conscious? And if humans are so easily fooled into seeing intelligence and consciousness in machines and algorithms that are not, what would it take for us humans to know whether or not a particular algorithm, AI algorithm, is conscious? So first, Seth makes it clear that the concept of consciousness is extremely nebulous. It's a difficult question, much less the answer. So let's just pause for a moment to discuss what we mean when someone talks about consciousness or sentience or intelligence. So as you can see on the slide, it says, I've got a definition of intelligence. Now, this may surprise you but science is really has a really difficult time defining intelligence. They have a difficult time defining consciousness and sentience. For intelligence, Seth offers two definitions: doing the right thing at the right time, and the ability to achieve goals in a wide range of environments. As you can see, these definitions are broad. It doesn't just apply to humans. It could apply to animals. It could apply to robots. It could apply, to a variety of things. So these are functional definitions. And though we do not yet have artificial general intelligence or the super intelligence, we've not passed the technological singularity. And again, AGI is an AI system that has attained or exceeded human level intelligence in at least all the ways that humans think they're intelligent. And so, although folks in Silicon Valley keep saying AGI is just around the corner, we're not there yet. So that was intelligence. Now let's consider consciousness, which is different than intelligence. Seth offers this general definition of consciousness. For a conscious organism, there is something it is like to be the organism. And this something it is like to be the organism is what the organism itself is feeling. It's feeling something like to be itself. It's a feeling. So consider if you've ever been under anesthesia. You exist and you are alive, but you have no intentional feeling of being yourself. When you wake up, you do. So that thing, whatever it is what we mean by consciousness. So likewise, I assume my dog has the feeling of being a dog. But I also assume that my laptop computer right in front of me does not have the feeling of being a laptop computer or any feeling at all, because it's a computer. So that thing, whatever it is what we mean by consciousness. Now, sentience generally means the ability to have feelings. So people often confuse sentience and consciousness, but for this episode, we're just going to say that sentience is a subset of consciousness. Now, by the way, when I just said that my dog has the feeling of being a dog, that's my assumption, because that's actually officially a controversial statement, at least to science, even to this day. And as you can see on the slide, a June 15th, 2024 article that was discussed on the BBC website that was titled, "Are Animals Conscious? How New Research is Changing Minds," and the correspondent was Pallav Ghosh. The article discusses that even though Charles Darwin back in the day believed that all animals are conscious, mainstream science does not now. They reserve consciousness as a uniquely human experience. According to the article, though, science believes that attributing consciousness to animals based on their responses, like to an experiment, that's a cardinal sin. So the argument went that projecting human traits, feelings, and behaviors onto animals had no scientific basis, according to them. And there was no way of testing what goes on in animals' minds. So the has no scientific basis part just means that scientists not only don't know how to define consciousness, but also don't know or how to prove or test if something is conscious, unless that thing can speak or describe what it is thinking about. Descartes said, "I think, therefore I am." But we only know that because he wrote it down. He only communicated in a human language. And since non-human animals cannot speak or write in a language describing their feelings, science just says non-human animals are not conscious. Except until recently, and that's the point of the article, some scientists are increasingly arguing that some animals indeed are conscious, and including some of the experiments that they've done on primates, bees, and dogs. So this is an ongoing argument that's not close to being resolved in scientific terms. But this does, however, illustrate the problem that we're facing when trying to discuss consciousness, not in dogs, but in algorithms. So it's even more complicated. As we saw with the scientific view of not wanting to believe animals are conscious, we see human biases of anthropocentrism, which is our tendency to view the world only from a human vantage point. In fact, there's a bit of exceptionalism going on here as well. Humans tend to think that they're not only the center of the universe, but they're unique in the ability to be in that spot. So therefore, the kind of more mainstream view is that humans are superior to all other forms of life. So in his paper, Seth notes that this bias leads to the perspective that we humans know we're conscious, we think we're intelligent, and we find we're special, so we assume that intelligence and consciousness go together. This way of thinking traces back at least to Descartes, for whom the immaterial, rational mind both endowed humans with the kind of consciousness that mattered and separated humans from all other animals. Now, related, humans have another bias that's complicating this entire discussion, and that bias is called anthropomorphism, which is our tendency to project human-like qualities onto things that don't necessarily have them. Think about how humans so easily thought that chatbots like Eliza and ChatGPT were sentient. After all, in the 1950s, researchers defined the field of artificial intelligence, and I'm using air quotes for those on the podcast, to describe their efforts to write computer algorithms that solve problems like humans do in order to address the question of can machines think? But because the word intelligence, they embedded that in the name of the field. I mean, the field is called artificial intelligence rather than, I don't know, computational statistics. Because intelligence is part of the name of the field, this makes even discussing AI algorithms a minefield of language games. Steve Woolgar described the issue like this: claiming the cognitive character of a behavior in describing certain behaviors as, for example, intelligent. One effectively construes a task as requiring intelligence for its performance. The task's performance is thus presumed to derive from some cognitive state or ability, the proverbial putting the cart before the horse. So we have embedded the cart before the horse by putting intelligence in the name of the field describing these computational statistics algorithms. So the point is, due to our human biases of putting all of this together, or due to our human biases of anthropocentrism, exceptionalism, and anthropomorphism, discussing consciousness in AI, we haven't made it easy for ourselves. So let's try to work this through, though. Now, that's the point of the paper. Seth goes into a lot more detail, but we're briefly now, we can walk through the final two questions. What would we need for conscious AI? And if we had it, how would we know it? So what would we need for conscious AI? First, we would need something called computational functionalism. Now, this means that computations of some kind are sufficient to instantiate consciousness. We can get consciousness through an algorithm, which is the way computers run code. Roughly, this assumes the consciousness is computational, meaning that with the right variables, you got the right parameters, inputs and outputs, we could have consciousness. This is a popular assumption, actually, but it has not been proven, obviously. And there are those who maintain that consciousness does not, in fact, work as a computer program, as you can imagine. But to have conscious AI, which is an algorithm, we would therefore need, at a starting point, computational functionalism to hold. We would need this property to hold. Second, to have conscious AI, we would also need something called substrate neutrality. In other words, we have our mental states, pointing at my head, and our own consciousness inside our brain. Our brain is the hardware, the wetware, if you want, the substrate that runs our mind. But obviously, there are different materials in the universe. Computer programs, for example, currently run on the substrate silicon chips in our computers. So to have conscious AI that's running as an algorithm, we would need substrate neutrality to hold. We would need something other than a brain, a human biological brain, to be able to have consciousness. We would need a silicon brain of some sort, for example, to be able to run this conscious algorithm. So while some argue that this is possible, and again, Seth goes into a lot more detail in his paper, for right now, let's just say a brain is the only thing that can run a mind. That's all we got, a brain. It's not been demonstrated that a silicon brain can be conscious. So the only substrate we have now is our brain, but for conscious AI to hold, we would need substrate neutrality. And in fact, Seth's paper argues for biological naturalism, that consciousness is a biological phenomenon. Just as no matter how detailed your computer simulation of rain is, for example, your simulation is never wet because you don't have water molecules. Thus, there's a connection between life and consciousness. Consciousness is a biological phenomenon that arises from neural and perhaps other biological processes. This doesn't rule out that one day we could have life that is not carbon-based, just as the properties of life are needed to have consciousness. Again, there's more nuance in Seth's paper, but based on these arguments, conscious AI will not be possible for current trajectories of AI models. Conscious AI will only be possible if we can create a machine that is functionally alive. Okay, so that was the second question. Our final question is, okay, assuming that we're able to do all of that, how will we know if the machine is conscious? In other words, we need a test of some sort for consciousness. And this might be a good point to remind ourselves that scientists, again, have no consensus on how to do this for non-human animals or machines. But Seth summarizes the issue with this following table, which is on the screen. It lists the types of tests we have used for determining intelligence, along with similar types of tests needed for consciousness. Now, I'm just going to describe it for those of you who are not watching the video, but we've got a 2x2 quad here. The rows are forward tests and reverse tests, and the columns are intelligence and consciousness. So we have a forward test for intelligence, a reverse test for intelligence, a forward test for consciousness, and a reverse test for consciousness. Now I'm going to walk through all of this, but I'm just describing the chart so you know how it's laid out if you're just watching this. So in general, there are two types of tests possible, forward and reversed. A forward test is a test that tries to assess whether the target has the particular property in question. So a forward test for intelligence tries to test, does this thing have intelligence, right? Depending on your particular criteria for intelligence. And remember, just defining intelligence, there are multiple ways to do it. Different scientists have different sets of criteria. But just to make this more concrete, you might have even read about or taken yourself an intelligence test, an IQ test. So the results of that test would indicate, hopefully, the presence of intelligence, but maybe even the level of intelligence, depending on the particular test. Now, again, there are many different types of intelligence tests because different scientists can't agree. They each want to do their own thing so they can get publications. But that's an intelligence test. But for consciousness, we would need to do something similar. We would need to have a forward test for consciousness to identify if that thing is conscious. Does it have the properties based on the criteria according to my specific definition of consciousness? So again, have fun. Pick your own definition of consciousness, identify measurable criteria, and then write down how you would assess those criteria. So if you can do all of that, you've got a forward test for consciousness. But there are also reverse tests. You might have even heard of the Turing test. Now, as a way to assess machine intelligence, Alan Turing, he went the reverse way because he didn't want to go through the trouble of defining intelligence, coming up with measurable criteria to create a forward test for intelligence. So Alan Turing proposed the following scenario as his reverse test for intelligence. You've got a judge, someone who's doing the assessing, and the judge is trying to assess the interactions of two participants that are hidden from view. The judge doesn't know who the two participants are. One participant was a human, the other a computer. And after a short time of passing written notes between the judge and the participants, the judge would send a question or something, and the participant would write a response and send it back to the judge, and the judge would read that. After that, if the judge was not able to determine which participant was the computer, then the computer was deemed to be intelligent, since the computer's communications were not identifiable as not being from a human. So this is a reverse test because you're not directly measuring the intelligence of the machine. You're assessing whether or not you're assessing what it would take for a human to attribute the machine with intelligence. In other words, as Seth points out in the paper, this is a test of human gullibility, not machine intelligence. We're assessing how gullible humans can be in believing some object is intelligent. So, nevertheless, a similar test for consciousness might be something, like in the film Ex Machina. And that test is called the Garland test. This is where a judge, knowing that the judge is interacting with machine, was still tasked with assessing whether or not the machine was conscious. That was in the actual movie. So it's called the Garland test for that reason. But again, as with the Turing test, the Garland test is just a measure of human gullibility. So though some people propose this type of test to measure consciousness, as we've just discussed, it's not. It's just a measure of how gullible humans are. So again, there's no consensus on how to define consciousness, nor how to determine observable and measurable criteria for consciousness. But we know we at least have some time to keep thinking about this to design a proper forward test for consciousness. That's what we need to do. So in conclusion, hopefully by now you'll at least believe me or agree with me that large language models are not conscious. And we likely won't have conscious AI anytime soon, at least if these arguments hold. However, there's an important topic. This is an important topic to think about for several reasons. And so here on the slide, and I'll walk through, are what I think are some key takeaways from Seth's paper and about our relationship with technology in general. First, Seth notes that as human beings, we have a habit of creating technologies in our own image and of projecting ourselves into the technologies we create. So as engineers and creators, our biases can confuse our efforts and can lead to unfortunate and unintended consequences when we release those technologies into society. You may have heard a lot of a lot of concern out there about biases in AI, these AI products that we're putting out into society. And the reason is just this. Researcher Kathy O'Neill said AI models are just opinions embedded in code. So the values, the biases, and we've talked about some of those biases so far in this episode, all of that human foibles go into the decisions that we're having these models make, which is why we have so many issues with AI in society. All right. A second takeaway is that we can at least better understand, hopefully, that consciousness will not result from just making AI faster or coming up with the next ChatGPT release or making it more powerful. We can't keep continuing on the same trajectory. So it might not even be possible with the current AI models that we have. A third takeaway is that a lot more work needs to be done to understand the relationship between consciousness and life, as well as between the mind and the brain. We've got a lot more work to do there. A fourth takeaway is that because there is a chance conscious AI is possible, as we sketched it out, there's a chance, it's worth thinking about what ethical rights a conscious AI might have. What rights do a conscious robot have? If only that's a mental exercise that's worth exploring, if only because that may help us humans better understand what ethical rights our fellow humans should have. Something that'll look at our history, obviously, and events going on in today's world indicate that, yeah, we need more work there too. Just understanding human rights, much less AI rights. So as a final parting thought to kind of wrap everything up, I want to highlight the closing. This is how Seth closed his paper, which to me was particularly meaningful. He writes, when in the early 1800s, at the age of 19, Mary Shelley wrote her masterpiece, Frankenstein, she provided a cautionary moral tale for the ages. The book is often read as a warning against the hubris of creating life. But the real Promethean sin of Frankenstein was not endowing his creature with life, but with consciousness. It was the capacity of his creation to endure, to suffer, to feel jealousy and misery and anger that gave rise to the horror and the carnage. We should not make the same mistake, whether in reality or even in appearance. And with that, I hope you enjoyed this dive into consciousness and AI. Let me know what your thoughts are. And I hope adding the video option to the podcast helped. We also added slides today, so I would love some feedback. Write it in the chat, either on the video, YouTube, or on the podcast. If you'd like to see more of this type of content, please give me some feedback here. Again, either on the video or you subscribe to my YouTube channel, subscribe to the TechnoSlipstream podcast. Check me out on Patreon. Give me some support there. I would love it either way. So thank you for being here today. And also over on the Patreon, if you do sign up, I've got transcripts of all the podcasts. I've got writings, discussions, lots of other stuff. So, you'll find all that there if you'd like to sign up. So thank you for listening and for watching. And until next time, I'll see you in the TechnoSlipstream.